Hi Year 11 and welcome to the second episode of Mathematical Mowbray Movies. In this lesson we're continuing on with similar figures, but this time we're assuming that we know that two figures are similar. Maybe the questions told us that they are, or maybe we've worked it out ourselves. And now we're moving on to performing calculations. So we're going to look at two types of calculations. We're going to be calculating an unknown length using the scale factor in a bit. But to start us off, we're going to perform the calculation of what we call the scale factor. So first of all, what do we mean by that term scale factor? All it means is how many times bigger is the image compared with the object. So I'm just giving you a little sketch here. I'm saying if this was my original object, this little triangle here, and this was my image, I'm saying how many times bigger is this image compared with the object. So in this case, it looks like it might be twice as big, for example. So the scale factor would be 2. But we need to perform calculations of that. So because this is just comparing the size of one thing to another, we do a division. So all I'm going to do is divide the image length. I choose one of the sides, doesn't matter which one, now that I know they're similar, divided by the object length. So the matching side on the object. So let's have a go at a calculation of scale factor. So we'll go back to our triangles that we had in the last video. So you can see I've got my image and I've got my object, and I've obviously worked out in the last video my different matching sides. So I'm going to choose any matching side to calculate the scale, matching sides to calculate the scale length. It doesn't really matter. So, or my scale factor, sorry. So my scale factor here is just an image length divided by an object length. And I'm going to choose one pair of matching sides. I'm going to choose DF and AC. You can pretty clearly see that they're the matching sides in the image and the object. So I'm going to compare the length of DF with the length of AC. And so I'm just doing 9 is the length of DF and 4.5 is the length of AC. And so 9 divided by 4.5 I know, 9 divided by 4.5 gives me 2. And so this here is my scale factor. This means that this image here is twice as big as this image. Wouldn't matter which pair of sides I choose for this calculation, they'd all give me the same thing. So we did it before, this calculation, to prove that they were similar, but now we're actually putting a name to that and calling it the scale factor. The second type of calculation that we need to do is calculating an unknown length using the scale factor. So in these questions, you're going to first of all need to calculate the scale factor and then use it. So let's have a look at a question that relies on this. So here you can see I've got a slightly less conventional question here. It's not really obvious where my two triangles are in this case, or where my similar figures are. So I'm just going to draw a quick little sketch to show you where they are. I've actually got a small one here. Okay, I've actually got that small one there, which has got these dimensions, 1.6 metres by 1.2. And then I've got my much bigger triangle, which is actually the whole triangle. So I've got these two triangles here. So I've got this one that's got a height of h, and I've got a length of 48. So these are my similar figures. Now I know they're similar because both have got a right angle. So both have got this right angle. Both share this angle in common. So this angle's the same in both triangles. And if these two are the same, then these two must also be the same. So I know that they're similar figures. I'm asked in this question to calculate h, to calculate this unknown. So these questions where you have to calculate an unknown length have two steps. The first step is calculate the scale factor. So to calculate the scale factor, I need to use the information that I know about the sides. So I can't use the scale factor I can't calculate the scale factor using these sides because one of them's unknown. but I know both of these sides, so they're the sides, the matching pairs that I'm going to use for my scale factor. So my scale factor, remember, is just an image length divided by an object length, and in my case, the ones that I've chosen to use are the 48 on my image and the 1.6 on my object. So on my calculator, I'm just going to type in what is 48 divided by 1.6. So it gives me 30. So this tells me that this triangle, obviously it's not drawn to scale, but this triangle here is 30 times bigger than this one. I should have put here that this is not to scale. Very important words to know. So now I use that information to work out my unknown. And you can probably think about how to do this yourself rather than just have me show you. But if you know that this triangle is 30 times bigger than this triangle, 30 times bigger, and you know that this side here is 1.2, how would you work out what this side's going to be? You know it's 30 times bigger. So I'll just give you a moment and think about it. How would you work out what this side h is going to be if you know this is 1.2 and you know h is 30 times bigger? The way you do that is multiply your known length by the scale factor. So in this case, these are matching sides. I'm going to multiply 1.2 by 30, since this triangle is 30 times bigger. And 1.2, again on my calculator, 1.2 times by 30, whoops, not by 300, 1.2 times by 30 gives me 36. So I know that this height here must be 36 metres. So that's using the scale factor to determine an unknown length. I'll now get you guys to have a go at the questions in exercise 302 from your textbook. So if you can have a go at those questions, and obviously just ask for a hand if you need some help. Good luck!